Technical debt, TD, is a metaphor in software engineering that represents the implied cost of future reworking resulting from earlier choices of easy but limited solutions. While TD can be beneficial in reducing maintenance time and cost in the short term, it can also lead to increased maintenance costs, reduced code quality and system reliability, slow feature development, and decreased team morale. This study aims to analyze practitioners' opinions on TD by surveying gray literature, using natural language processing techniques like topic modeling and sentiment analysis. The study collected 2,213 forum posts and articles from 3 mainstream technology forums, identifying 8 main topics and 43 subtopics related to TD. The topics include unclear roles and lack of engagement, active management supporting collaboration, and the impact of TD on source code. The study also used ChatGPT to support topic interpretation. The research questions guiding the study include: what aspects are commonly discussed when practitioners talk about TD? What are the issues about TD that practitioners commonly complain about? What benefits can paying TD bring? The study found that practitioners have opinions on TD and, based on their needs and constraints, they find themselves bound to accumulate TD to meet expectations and deadlines. The study's methodology involved collecting data from popular technology forums using the search query, TD, and processing the data using NLP techniques. The study's results provide a comprehensive understanding of practitioners' opinions on TD, including the benefits and drawbacks of incurring TD. The study's findings can inform future research efforts, which should focus on developer issues with TD, AI-driven TD detection and management, and the effect of TD on current software development methodologies such as DevOps. The study's contributions include large-scale opinion mining on TD, the use of large language models for data extraction and synthesis, and the identification of 8 major topics and 43 subtopics for future research and practitioners' reference. The study's results can help practitioners and researchers better understand the complexities of TD and develop effective strategies for managing it. This study examines the opinions and discussions of practitioners on technical debt, TD, in software development, leveraging data from 3 prominent online platforms: Stack Overflow, Medium, and dzone. The research process involves data extraction, pre-processing, informativeness filtering, topic modeling, topic filtering, and opinion mining. Data extraction employed different strategies for each platform due to varying API availability and crawling policies. For Stack Overflow, API-based content crawling was used to retrieve questions and answers related to selected tracing tools. Medium's policy prohibited direct crawling, so historical articles with specific tags were obtained using tools like Beautiful Soup. dzone adopted a hybrid approach, combining manual search and Beautiful Soup for article content crawling. The data analysis process, illustrated in Figure 2, consists of 5 steps. Pre-processing involves dividing texts into sentence-level instances, building bigram and trigram models, and performing text processing activities such as lemmatization. Informativeness filtering uses a trained text classifier to identify sentences containing useful information about TD. Topic modeling detects main topics using techniques like Gibbs sampling, Dirichlet multinomial mixture, GSDMM, or traditional latent Dirichlet allocation, LDA. Topic filtering maps each sentence to its corresponding topic, and opinion mining extracts collective sentiment regarding each topic. The study utilizes ChatGPT-driven techniques for topic interpretation, adapting methods from Janes et al.'s study. ChatGPT, an artificial intelligence chatbot developed by OpenAI, supports effective topic interpretation and summarization. The newly released GPT-4 model is employed for topic extraction, demonstrating higher reasoning capacity and conciseness compared to the legacy GPT 3.5 model. The research ensures verifiability and replicability by publishing the complete raw data in a replication package. The results, presented in Section 3, address the proposed research questions, providing insights into practitioners' opinions and discussions on TD in software development. The study presents a comprehensive analysis of technical debt, TD, in software development, leveraging a large-scale dataset of textual data from social media platforms. The research employs a 4-step approach: preprocessing, informativeness filtering, topic modeling, and topic interpretation and mapping. Preprocessing involves retaining only natural language sentences from crawled data, eliminating unnecessary content such as source code, URLs, and publishing dates. The Natural Language Toolkit, NLTK, is used for sentence tokenization, and LangDetect and HTML2 text packages are employed for filtering non-English texts and HTML markdowns. This process yields 3,044 sentences from Stack Overflow questions, 965 from Stack Overflow answers, 49,903 from Medium articles, and 6,801 from Zone posts. Informativeness filtering utilizes a naive Bayes (NB) classifier or expectation maximization for naive Bayes (EMNB) classifier to identify informative sentences. The study compares the performance of both classifiers using 3,000 manually labeled training data, with the NB classifier achieving an accuracy of 0.843. This classifier is then used to filter informative sentences, resulting in 36523 sentences. Topic modeling employs the collapsed Gibbs sampling Dirichlet multinomial mixture (GSDMM) model to extract topics from the filtered sentences. The model is trained with 30 iterations, alpha equals 0.25, and beta equals 0.15, and the upper bound topic number parameter k equals 30. This process yields 20 topics, with 35,521 sentences, 97.3%, associated with 8 main topics. Topic interpretation and mapping involve analyzing the 8 main topics, including the true cost of TD, balancing short-term gain with long-term pain, and managing TD, a team-centric approach. Subtopics are identified, such as the long-term consequences of shortcuts in software design, and solving TD through team collaboration. These topics and subtopics provide insights into the concerns and strategies of practitioners regarding TD and software development. The study highlights the importance of balancing short-term gains with long-term costs, managing TD through team collaboration, and incorporating regular reduction of technical debt into the product lifecycle. The findings provide valuable insights for software developers, project managers, and business leaders to effectively manage TD and ensure sustainable software development. Effective management of technical debt, TD, is crucial for software development teams. Practitioners emphasize the importance of collaboration, understanding, and proper tools and strategies to mitigate TD. To manage TD, teams must allocate resources, prioritize tasks, and address TD and sprint backlogs. Agile teams can benefit from continuous TD management, where clean code is linked to agile development and continuous delivery. Practitioners highlight the significance of understanding TD as a team, including the role of engineers, architects, and company leadership. Decision-making activities require team involvement, and communication gaps can lead to poor decision-making. Engineers play a crucial role in managing TD, as they are often the direct inducers of TD. To pay down TD in agile sprints, teams must allocate resources, prioritize tasks, and address TD and sprint backlogs. Prioritizing TD-related tasks in sprint backlogs is essential, and teams should assess each item of TD, understanding its impact on the product and user. Consistently including TD in sprint backlogs with elaborate estimation and prioritization ensures that it is paid down regularly. The business impact of TD is a critical concern, as unchecked TD can impact development efficiency, software product quality, and customer satisfaction. Practitioners acknowledge that TD can hurt businesses in the long run, resulting in costs from fixing problems, reputational risk, or regulatory action. Reducing TD means limiting its potential cost on the business level, but organizations often have little idea of how much technical debt they carry in their code. To track the cost of TD, tools like StepSize can help capture and track TD from workflow, allowing teams to quantify its cost to the business and prioritize the most important debt. TD can also impact team morale and productivity, and implementing a process for managing TD can positively influence engineering team morale and customer satisfaction. Evaluating the business risks of TD is critical, and practitioners propose building a debt limit and quick feedback to reduce risks. Measuring and managing technical debt, TD, is crucial for software project teams. Practitioners use various metrics, such as the number of bugs, code quality scores, and impact on maintenance cost, to track and manage TD. However, calculating the exact level of TD can be challenging, and the number of violations in terms of standards or defined rules can be a useful variable for TD measurement. SonarQube is a popular tool used for measuring and managing TD, providing features that support efficient refactoring to reduce identified TD. In product development, managing TD is a necessary aspect of maintaining a product focus. Practitioners discuss the need to balance quality and speed in product development, as prioritizing rapid delivery over quality can lead to increased TD. Product managers, engineers, and product owners must balance this trade-off to maintain quality and long-term value. In fast-paced business environments, product teams face the dilemma of delivering new features quickly or focusing on quality and incurring TD. Effective management of TD involves prioritizing maintenance work, such as bug fixes and code improvements, while working on new features. Project teams must assess the long-term impact of TD and allocate sufficient time to address it alongside ongoing development tasks. Integrating TD management into feature development is crucial, as every new feature adds debt or creates a placeholder for future debt. Testing plays a vital role in managing TD, particularly in development environments with continuous integration and deployment. Automated testing can quickly identify and address bugs, ensuring that the development process does not add to the TD. Testing is also essential for maintaining code quality and reducing the long-term cost associated with TD. In microservice architectures, testing is key to managing TD, particularly when changes in code and architecture are frequent. Opinion mining using the Vader method can assess the sentiment of each informative sentence and the overall sentiment of each topic. By comparing the sentiment percentages of each main topic to the average sentiment percentage of all sentences, the benefits and issues of each topic can be determined. The research paper discusses the concept of technical debt, TD, in software development, focusing on its implications and management strategies. It highlights that TD is a common issue in software development, where quick fixes are often prioritized over long-term sustainability. The paper presents a sentiment analysis of various aspects related to TD, including its true cost, management, payment in agile sprints, business impact, measurement tools, role in product development, balancing new features, and code quality. The sentiment analysis reveals that practitioners generally have negative opinions about the long-term consequences of TD, but they view it positively as a quick solution. There is also a positive sentiment towards the high cost of TD in financial terms and the comparison between short-term gains and long-term costs. However, the discussion on balancing speed and sustainability in TD payment is viewed negatively. In terms of managing TD, the paper suggests that team collaboration, specific tools, and strategies can help reduce TD. The role of engineers in managing TD is highlighted, along with the importance of team involvement in decision-making. The business impact of TD is significant, affecting company risk, team morale, and productivity. Measuring TD using various tools and metrics is crucial for understanding its extent and managing it effectively. The paper also explores the trade-offs between quality and speed in product development, where TD plays a critical role. It emphasizes the need for balancing new features and TD in software development, allocating resources appropriately, and integrating TD management into feature development. Finally, the importance of code quality and testing in managing TD is discussed, highlighting the use of data metrics, automated testing, and continuous improvement of code quality. Overall, the paper provides a comprehensive overview of technical debt, its implications, and strategies for managing it effectively in software development. It emphasizes the importance of balancing short-term needs with long-term sustainability and the critical role of team collaboration, measurement tools, and code quality in managing TD. The paper discusses the collective opinions of practitioners on technical debt, TD, in software development. It highlights that practitioners have mixed opinions on managing TD, with some viewing it as a necessary evil for short-term gains, while others are concerned about its negative effects. The paper also explores various strategies for managing TD, including team collaboration, adopting proper tools and strategies, and enhancing collective understanding of TD. It further discusses the importance of paying down TD in agile sprints, understanding its business impact, and measuring TD with appropriate tools and metrics. The paper also touches on the role of testing in code quality and the balance between new features and TD in software development. The paper uses natural language processing (NLP) techniques to analyze textual data from various sources, including articles and posts from technical forums and social media platforms. It identifies 8 main topics related to TD and further models these topics to obtain subtopics. The sentiment analysis reveals that practitioners have positive opinions on certain strategies for managing TD, such as team collaboration and adopting proper tools, but negative opinions on issues like unclear roles and overemphasizing business risk. The paper also discusses potential benefits of active managing and paying down TD, including quick delivery and fixes to the code base, collaboration among team members, and a more sustainable and productive software development lifecycle. It highlights the importance of balancing the need for speed with the ability to keep high code quality. Finally, the paper addresses threats to validity, including construct validity and internal validity, and discusses strategies to mitigate these threats, such as careful selection of search terms and a broad search string to ensure a comprehensive set of results. The paper discusses the application of inclusion and exclusion in a multivocal literature review on open tracing tools, considering both academic and gray literature. It highlights the importance of mitigating threats to validity, such as researcher opinions and experiences, by evaluating sources independently. The study also addresses external validity, conclusion validity, and related work in the field of technical debt. Technical debt, TD, is a metaphor that reflects technical compromises that ultimately negatively affect source code maintenance. Various previous studies have investigated its impact, evolution, and management. For instance, Li et al. Surveyed 94 studies to systematically map the debt type, highlighting ambiguity in the broad definition of TD. Similarly, Ernst et al. Surveyed 1,831 participants and conducted follow-up interviews with 7 software engineers, proposing a technical debt timeline to improve management and tooling strategies. Recent studies surveyed the opinion and technical experience of developers on TD. For example, Rocha et al. Presented the results of an online survey with 74 participants from the Brazilian software industry, aiming to understand why technical debt is introduced, eliminated, and managed, mainly at the code level. Raymak et al. Investigated TD by preparing and conducting a family of surveys, receiving 653 valid responses from 6 countries. The paper differentiates from previous related work on surveying developer opinions for the scope, methodology, and size of the surveyed opinions. It employed 2 novel methodological choices for the related work: the use of LLMs for data synthesis and the broader scope. The study aimed to investigate, collect, and classify developers' opinions into major topics to provide a comprehensive and concise view of possible new research opportunities and practitioners' suggestions for consolidating good practices while averting non-optimal ones. The paper concludes that future research efforts should focus on AI-driven TD detection and management, as well as an analysis of the effect of TD on current software development methodologies such as DevOps. It also provides a list of references for further reading on the topic of technical debt.